Hey, selected topics in geometry, how's it going? This is going to be our very first video lesson of the year. So what we're going to talk about is the distributive property, right? This is going to be the beginning of our unit on equations and inequalities. So you might have done the distributive property in the past, but it's never going to hurt to kind of go back over some of this kind of stuff. All right, so the first thing we're going to talk about is, our learning target, right? We want to be able to rewrite an algebraic expression without parentheses using that distributive property, right? Because parentheses kind of get in the way a lot of the time. Sometimes you can simplify stuff that's in them. This is going to be for some of the times that we can't, and we got to figure out what we can do with that. So we have the distributive property of multiplication over addition, right? So what that means is that if I ever have a problem that looks something like this, right? A, B, and C might be numbers, they might be variables, they might be, like B could be the same thing as like 4x in a given problem, right? We won't really know until we get into the problem itself, right? So what we're going to have is that when we have a problem that looks like that, when we're distributing, we do A times the B, right? So when I'm getting my answer for this problem, that's going to be whatever A times B is. And then we got to go ahead and do the same thing. We have to distribute it out to everything in the parentheses so that A also has to multiply C. All right, so when we get that chunk, it's going to be whatever A times C is. All right, so the reason we call it multiplication over addition is that this little symbol in the middle, right, that little plus sign, stayed the same throughout, right? So we had a plus sign there. That meant that we had a plus sign a little bit later on. Right? We are going to get into a little bit of like what happens if there's a negative in there, but let's just practice with this for now. So if I had 4 and then x plus 3 in parentheses, right, that means that I'm going to take that 4, I'm going to distribute it in there to that x, right? And that part of my answer is going to be whatever 4 times x is, which is just 4 times x, 4x, right? Then we go ahead and we do the same thing for 4 times 3. That's going to give us 12. Right? And then in the middle, we had a plus sign before. We're still going to have it be a plus. Right? Nothing has really changed signs at all. Right? So hopefully that doesn't seem too bad. I'm going to clean up that 12 a little bit. Oh, that's even worse. All right, so there we go. 4x plus 12 is our answer. We have rewritten that expression. I don't know what that's going to come out to be, right? Like, I don't know what x is. I can't really get any further. But that's all we're really trying to do. All right, let's try another one out. So, this one, we've got 5, and we're going to multiply it into 2x. So when we've got something like 2x, we're going to multiply the pieces that look like they go together, right? So the 5 can multiply the 2 and give us 10. And then that x is still along for the ride, right? Nothing got rid of it, right? It's still going to be there. The other piece of what we're doing is just going to be 5 times 5, which is 25, right? So again, because we had a number here and a number there, right? A 5 and a 2, we could multiply those ones together, right? That's where we got that 10 from. Oh man, what if there's more stuff? Well, all that means is that we're just going to do it in a couple more steps, right? 4 times A is 4A. There's a plus sign after that, so we're going to put a plus sign down there. We then move into the middle piece, right? Every single chunk gets its own bit of distributive property. So then we've got 4 times 2B, right? So the 4 can multiply with the 2. That'll give us 8. And then again, that B sticks around, right? It doesn't just disappear when we do that, right? It's still around. And then let's choose another color for that last piece. We've got 4 times C, right? There's a plus sign there. And then 4 times C is just 4C, kind of like that 4A at the beginning. Once we get to there, I can't actually do anything else, right? I have A's plus B's plus C's. None of those really smushed together with addition, so that's our final answer right there. Oh boy. Oh dear. What happens if there's a squared? Yikes. So x squared is like its own thing, right? The squared is like attached to the x. So we're not really going to do anything with the squared when we're talking about the 7, right? All that's going to do is that's just going to give us 7x squared. right? We're just popping that 7 right on the front. To take a little bit of a closer look at it, actually, right? What's really going on is that in front of that x squared, it has a coefficient of 1, right? There's a little invisible 1 in front of there. Just like when we get to the z, there's technically a little invisible 1 in front of that, right? It's one single z, so we can put a 1 there. So the 7 multiplies with that red 1, which gives us the 7 in front of x squared, right? So we are still doing the same thing of multiplying the right pieces together, right? It's just got a little bit of extra bit there. All right, then we move on to the middle piece. Right, we do 7 times 3y. All right, so again, the 7 can multiply with the 3. That gives us 21. And then that y has to come along. All right. Then we move on to the z at the end. Right, 7 times 1 is 7. And that z comes along, right? We didn't get rid of it. It's still hanging out. That's as far as we can go with these problems, right? I can't add x squareds and y's and z's. They're all different variables, so we can't smush those, right? So that's all we got to get to. So I said we take a look at what happens when you have subtraction kind of floating around in there. So we have the distributive property of multiplication over subtraction, which is just a big, long way of saying that, if you have something similar to what we had up top, it's a b, and a c, right? But there is subtraction in the middle, then you got to be a little bit more careful, right? So when we go ahead and go through this one, right, we're going to have whatever a times b is, right, which is just ab. And then when we move on to that next piece, right, because there's subtraction in front of c, we're going to kind of group it together with that, right? So you're going to take whatever sign comes in front of that chunk, and that's what's going to come along. You might have noticed that in the previous ones, right, when we did 3y in that example 4 that's on the screen still, it had a plus sign, so it was a positive 3. That 7 on the outside times that positive 3 gave us positive 21. Oh gosh, how did I do that? Right? Same thing goes for that plus 1z, right? It was a positive 1, so it turned out to be positive 7 at the end when we multiply. All right, so when we do this down here, right, it's a times negative c. Right, so what that's going to do is that's going to give us negative AC. Right, you can also kind of think about it as just kind of dragging the subtraction sign along with it, but sometimes we get into situations where it's a little better to think about it as, all right, this is the sign that's in front of C. That's what we're going to take. All right, so let's try some of these out. Right, first ones aren't going to be too bad. Pretty similar to the ones we were doing earlier. Right, 3 times x is 3x. Then we move on to 3 times, and again, I'm going to think about it as negative 7. 3 times negative 7 is negative 21. Right? That's all we can get to, right? I can't combine the x's with the 21, right? So we're done. Right? Moving on to the next page there, so if you haven't flip now. This one's a little bit trickier, right? So this one's got a negative 11 out in front, right? We need to make sure that we group that negative with that 11. So when I'm multiplying here, right, this is now negative 11 times that regular old 5. So negative 11 times 5 is negative 55. Okay. When we do the second piece, we multiply it into that negative 6x. Right, I'm thinking about it as negative 11 times negative 6, which is positive 66. And then that x comes along. Right, so when you have a negative times a positive, it comes out as negative, right, when there's only one of each. When you have two negatives multiplying, they switch back to being positive. All right, so that's something to be pretty careful of when you're going through problems like these. All right, what I'd like you to do is pause here, try 7 on your own. Right, there, you got some space there. If you get it wrong, not a big deal. And then unpause when you think you've got it and check it out and see what I do. All right, so hopefully you tried 7 on your own. What I'm going to do is this is 3 times 2x. So the 3 and the 2 multiply to give us 6, and the x comes along. We've got 3 times negative 3y. Right, so 3 times negative 3 is negative 9. With that y hanging on for dear life. And then that last piece is 3 times negative 6, right? Again, grabbing the sign that comes in front of it, right? So 3 times negative 6 is negative 18, right? And that's where we get to, right? We get 6x minus 9y minus 18, right? Give yourself a pat on the back if you got that one right. So then things get a little bit trickier, right? We're asking what happens when we have variables inside and outside of the parentheses, right? So on these ones, we have some x's on the outside that we're then going to have to multiply onto the inside, right? So let's take a look at this. So on this first one, we've got 2x, and we're going to multiply it into 5x, right? So a little bit earlier on, I mentioned multiply the things that go together. So the 2 and the 5 can multiply to give us 10, and then the x's can multiply because they're the same thing, right? So x times another x would give me x squared, right? A brief little thing to the side, right? I am going to come back to this problem in just a moment. When you have variables, right, if I have x times x, that does give me x squared. Some of you might be thinking, why isn't it 2x? Well, that's what you get when you do x plus x, right? So when you're multiplying things together, right, when you've got this multiplication going on, ooh, that's really big. Let's make that a little smaller. We've got x times x. That's when we change the variable, or the exponent, rather. When you're adding them, that's when you change the coefficient that's out in front. All right, so be a little careful with that. I've seen people make mistakes with that in the past. So multiplying changes the exponent, adding changes the coefficient. Okay, so that's what we're going to get out of 2x when we multiply it into that 5x. And then we got to do it with this other chunk, right, times this negative 3. So the 2 and the negative 3 can multiply to give me negative 6. The x doesn't have anything to multiply with, so it just comes along and stays the same. Cool, we're done with that one, right? That's really all that's going on there. All right, let's try another one out together. This one's got 2 different variables, right? It's got an x and then it's got a y a little bit later on. So first things first, right? Pretty similar to the last one. We have a 3x times a 2x. The 3 and the 2 can multiply to give me 6. The x's multiply to give me x squared. All right, after that, move into that negative 5 in the middle. The 3 can multiply that negative 5 to give negative 15. And then that x just comes along for the ride. All right, last but not least, we've got 3x times positive 2y. All right, so the coefficients are not going to be too bad, right? The numbers, the 3 times the 2 is going to give us positive 6. And then x times y. Well, I can't squish them together, right, because they're different. I can't turn them into xy squared or anything like that. So all I can do is I can just put them next to each other like that, right? So whenever you have 2 variables that aren't the same, you know, you can't change their exponents. You just got to smush them right next to each other like we did there, okay? Oh, dearie me. This one looks pretty awful. Let's talk it through. We've got 4xy times 6x. All right, so 4 times 6, easy peasy, 24. And then there's a whole lot going on with these variables, right? We have an x and a y on the outside, and then just an x on the inside. All right, so again, take it one thing at a time. Multiply the stuff that goes together. You have an x on the outside, you have a single x on the inside. If you multiply those, they'll give you x squared, right? As for that y, right, it's just on its own, right? There isn't any other y, so all you're going to do is just bring it along, right? The place that you put that squared, that exponent of 2, really does matter, right? Because the x's multiplied together to get that x squared, right? Don't put your squared off at the end of everything, because that y is not squared, right? Let's take a look at that piece in the middle, right? We've got 4xy times negative 3y. So 4 times negative 3 is negative 12. And then again, same thing with the variables, right? That x doesn't have anything to multiply with, so it stays x. The y now has a y that it's going to get multiplied by. So then that becomes y squared, right? So Hopefully that kind of makes sense, the difference between the stuff we did in red and the stuff we just did in blue, right? It depends on which one you're having an extra one multiplying with. And then last but not least, we're going to multiply by positive 4 there. So 4 times 4 is 16, positive 16. And then the x and y don't have anything to multiply with. You just bring them along, right? You just keep on scooping them up and keep going, right? So I will say that if these ones are making sense, that's awesome. If you're still a little shaky on them, this is definitely something that we will talk about when I see you guys in person. We'll make sure to talk about these in particular because they do get a little tricky if you're not used to it. All right, so don't be afraid to ask questions next time I see you in person. Oh boy, everybody's favorite. What happens when we do fractions? So, it's a little bit weird to think about the distributive property as being able to break up fractions, right? But what we're going to do here is we're just going to rewrite them. So 36 plus 3x all divided by 18. Distribution kind of lets us, chunk out that divided by 18. So it's kind of like we're going to split up the fraction a bit. So instead of 36 plus 3x, we can break it where that plus sign is. Right? We can do 36 over 18, put a plus sign in the middle, and then have 3x over 18. Right? So why might we want to do that? You might be thinking, like, that makes it look even worse. So the reason that we're doing that is because then we can take these different chunks and simplify them on their own, right? 36 divided by 18, if I plug that in a calculator, that's just going to be 2, right? So that means that we can simplify that first chunk into just 2, which is pretty nice. The other piece has a 3 on the top and an 18 on the bottom, right? So if you remember how to reduce fractions, if I have 3 out of 18, I can divide them both by 3. That's the same thing as 1 over 6, right? So what I can do is I can turn this into 1x over 6, right? You can kind of reduce the numbers in those fractions, right? I'm not going to lie to you. Sometimes this is more useful than other times, right? This is not something that's going to make fractions super easy every single time you run into them, but it's a good skill to have in your back pocket because sometimes it does make problems easier, right? Try this one out on your own. Pause here for a minute. See if you can break it up the same way I just did with number 11 and then unpause when you think you got it. Again, if you get it wrong, not a big deal, right? We're just practicing. All right, so on this one, I can break this up into 30 divided by 10 plus 2x divided by 10. All right, so same idea as the last one. 30 divided by 10 is just 3. Then that other chunk, 2x over 10. All right, on the last one, we could reduce the fraction with the numbers, right? 2 over 10 is the same thing as 1 over 5. So I can call this 1x over 5 instead. All right, and again, like I was saying before, this doesn't make fractions like, oh, wow, it's all so easy now. That looks much better, right? But it is a good tool to have, right? Because sometimes being able to get to this point where the 3 is by itself is going to be helpful when we're solving things out, right? You never know. Whoops. Sorry. There we go. All right. We got a little bit more to talk about, and then we'll be done for the day. We got to talk a little bit about additive inverses, all right? So this is just a big fancy way of saying, I've got two numbers that sum, like when you add them together, that sum to 0. Right? So it's like, we're going to state these additive inverses. The additive inverse of 10 would have to be negative 10, right? Because when you add those two numbers together, you get 0. The additive inverse of 5 is negative 5. All right, so it's kind of like just taking the opposite of whatever you have. The opposite of negative 16 is positive 16. And then similarly, the opposite of negative 201,942 is positive 201,942. Right? Nothing tricksy going on, just kind of taking the opposite. Right? And that's going to, help us out a little bit here and there. We're just finding the opposites of things. All right, we've got some properties we got to talk about. The opposite of opposites property, right? That's saying that if I have a situation like this, if I have the negative of negative a, right? Then when I simplify that down, that's just going to give me positive a, right? Two negatives cancel each other out. So if you ever have a situation like that, think about it like you're multiplying it, right? It's like a negative times that other negative on the inside of the parentheses. They cancel, and you're just left with a positive. We've also got this multiplication property of -1. If I take something a and I multiply it by -1, that's just going to give me the same thing, but negative, right? It's just going to give me the opposite. If we're talking about the opposite of a sum, right, that's talking about if you have a case like this, where it's the negative of, and then in parentheses, a plus b. What I would like you to think about this as is, imagine, if you will, that there's a little invisible 1 in front here, right? If I took that little invisible 1 and I distributed it into both of these pieces, right, we know what's going to happen. It's going to change them to be their opposites, right? So my answer, when I get out of that, is going to look like this. We're going to get negative a and then minus b. Right? So it's flipping all the signs on the inside to their opposites. The same thing is pretty much true for the opposite of a difference property. Right? If I have the opposite, or the negative of a minus b in parentheses, it's going to flip all of the signs to their opposites. Right? So that a was positive on the inside, right? It didn't have anything out in front of it, so we think of it as positive. It's going to become negative a. As for the b was negative. We're going to change it into, oops, what the heck is happening there? It's thinking I want to draw shapes. We're going to change that into positive b, right? The sign is flipping to its opposite. Okay. So we're going to try and rewrite a couple things using these properties, and then we're done. So again, you can think about them as distribution, right? If I pretend that there's a little invisible 1 out in front of there, you can think about it as -1 times 15y. Well, -1 times 15 is -15, and that y just comes along for the ride. If I take that same -1, multiply it over to the 3, -1 times 3 is -3. Right? That's where we're going. Right? If you're a little bit, able to kind of see what's going on, just flip the signs to their opposites, and that's really all that's going on. Right? So again, I'll do this one the same way as I did the first one, and then the last one we'll try with that little shortcut. So this one, if I have -1 times 16x, well, that's going to be -16x, right? Just flip it. If I have -1 times +4, all of a sudden that's -4. Okay. And then this last one down the bottom, right? We're going to flip the signs. I'm going to do this one a little bit of the shortcut way. If you want to pause here and try it on your own, see if you know what's going on, not a bad idea. So I know that this negative on the outside is going to flip each of these signs on the inside to their opposites. So instead of -7x, we're going to have +7x. Right? Instead of -9, we're going to have +9. Right? That's really all we're going with those. All right, so hopefully that makes sense. As I mentioned in class, you do not need to do the practice problems at the end of these notes. We're going to talk about those when I see you again next time. So for now, you're good with this one. Be sure to check on Google Classroom for the other lesson and whatever else I might have you doing, and I'll see you next time.